Okay, fourth and finally, in this P chapter notes lecture, we want to discuss imaginary numbers. So just a couple of things to remember here from Algebra 2, that I is equal to the square root of -1, which means that if you square it, you're going to get I squared is equal to -1. And recall that the complex conjugate of A plus BI is A minus BI. So just a quick example there on what I mean is that if I have the imaginary number 5 plus 3i, then the conjugate of that number is going to be 5 minus 3i. Or if I have -2 plus I, the conjugate of that is going to be -2 minus I. So to find a conjugate, you just change the middle sign, or another way to say that is you change the sign of the imaginary part only. Okay, so 4 basic examples to get us going here. First, addition and subtraction. Example 1, we're going to add 2 imaginary numbers, and this is pretty straightforward. It's essentially just combining like terms. So notice here that I have a real part 3 and a real part -4 here, and so when I add those together, I'm going to get a real part of -1. And then I also have imaginary parts that can be added together. Here I have a 4i and a -2i, and when I add those together, I'm going to get a positive 2i. And that's it. It's literally just collecting like terms. Now, in example 2, we have essentially the same thing, it's just subtracting. So I have -6 as a real part minus -3, so that ends up being -6 plus 3, which is -3 for my real part. And then the imaginary part is going to be -5i minus 2i, and that's going to end up giving me a -7i for my imaginary part. Okay, letter B, multiplication. So when we multiply 2 imaginary numbers, we're essentially just foiling out or distributing in order to multiply here. So we would start with 1 multiplied by 3, which would be 3, and then 1 times -2i, which would be -2i, and then multiply the inside terms together. So 3i times 3 would be positive 9i, and then 3i times -2i will be -6i squared. Now, remember back up here that I squared was -1, and so that means that this term right here actually becomes -6 times -1, which ends up becoming a positive 6. And so this is going to be 3. I'm going to go ahead and collect my like terms here in the middle. So this -2i plus a 9i is going to give me plus 7i, and then plus 6 is what that last term becomes. And then the last thing I need to do is just collect my real parts here, this 3 and this positive 6, which is going to end up giving me 9 plus 7i as my answer when I multiply those together. Okay, example 2, we've got 2 plus 3i times 2 minus 3i squared. Now I'm going to help you out here and show you a really fast and easy way to do this. Remember that 2 minus 3i squared really just means take 2 minus 3i and write it twice and then multiply out. And I'm actually going to multiply these first 2 parentheses together first. And what you should notice is that they are conjugates of one another. And I'm recalling that word conjugate back up there. 2 plus 3i and 2 minus 3i are conjugates of each other. And when you multiply conjugates of each other, watch what happens. I'm going to multiply the first 2 terms. 2 times 2 is going to give me 4. Now when I multiply the outside terms, 2 times -3i gives me -6i. I'm going to write that up here just sort of out of the problem. And then when I multiply the inside terms, 3i times 2, that's going to give me positive 6i, and those 2 things end up canceling out. And so I don't really need to multiply the outside and the inside terms, but I do have to multiply the last terms. So 3i times -3i is going to be minus 9i squared, and then the other 2 minus 3i just gets copied down. Now, what do we know about minus 9i squared? From the discussion in example 1, we know that really turns into plus 9. So this is going to be 4 plus 9, which ends up giving me 13. and then times 2 minus 3i, and now I just need to distribute my 13 in order to end up with the answer, which is going to be 26 minus 39i. Okay, finally in our notes, we want to talk about how to divide two imaginary numbers and then how to simplify something that's I raised to some power. And so in example 1, for division, what we're going to do when we simplify this is we're going to multiply by the conjugate of the denominator. And so if you look at that denominator, 1 plus 2i, the conjugate of that would be 1 minus 2i, and we're going to multiply the numerator and denominator by that 1 minus 2i. Okay, what that's going to end up giving us in the numerator when we distribute here is it's going to give us 2 times 1, which is 2, and then 2 minus 2i is going to give me minus 4i. 3i times 1, which is here, is going to give me plus 3i, and then finally 3i times negative 2i is minus 6i squared, which we know is going to end up being plus 6. Now, in the denominator, we're multiplying conjugates together. And from our previous discussion, when we multiplied, if I multiply conjugates, I only have to multiply the first and the last term. So 1 times 1 is going to give me 1, and 2i times negative 2i is going to give me minus 4i squared, which we know is going to become plus 4. And so this is going to equal to, in the numerator, watch carefully what I have going on here. I'm going to try to use a different color to make it clear. I've got a 2 and I've got a positive 6 because of the I squared. So 2 plus a positive 6 is going to give me an 8. And then I'm going to collect my other terms together, my two imaginary terms. Negative 4i plus 3i is going to be minus 1i. Now, in the denominator, we've got 1 minus 4i squared. But remember, minus 4i squared is really plus 4. So 1 plus 4 is going to give me 5. Now, we want to write our answer in A plus BI format. And this is not currently A plus BI format. So to get it to that format, we do what's called splitting through the numerator. So that means I'm going to take the first term in the numerator and put it over the denominator. And I'm going to take the second term in the numerator, which is 1/5, and then multiplied by I. Okay, example 2 is very similar, so I'll walk you through this example as well, just to give you one more to look at here. So just as a reminder, we're going to start by multiplying by the conjugate of the denominator, which is going to be 3 plus 2i. And when I FOIL that out in the numerator, I'm going to have 2 times 3, which is 6. And then 2 times 2i, which is plus 4i. And then multiply I by both of those. So I times 3 is going to be 3i. And I times 2i is going to be plus 2i squared. In the denominator, since we are multiplying by conjugates, we only have to do the first terms multiplied together and the last terms multiplied together. And so 3 times 3 is 9. And negative 2i times positive 2i is going to be minus 4i squared, which I remember is going to be really plus 4. Okay, so if we look at the denominator first, 9 plus 4 is going to be 13. And just like we did on the previous problem, we've got a 6 here. And this is really a minus 2 since that I squared goes away and changes the sign of that term. And so that's going to be a 4. And then I have 2 imaginary terms here in the middle that I can add together, and so that's going to be plus 7i. And the final step is just to split through the numerator, as I said before, which becomes 4 over 13 plus 7 over 13 multiplied by I. Okay, last thing is that we want to discuss how to simplify powers of I. And so I just need to do some preliminary discussion over here. And the first obvious fact is that I is equal to I. Hello, duh. I is equal to I. Not a groundbreaking statement there. Now, if I do I squared, I know that I squared is equal to negative 1. If I then multiply both sides of that equation by I, then I squared times I gives me I cubed, and negative 1 times I gives me negative I. So I cubed is really the same thing as negative I. And then if I multiply both sides of that equation by I, I'm going to get I to the fourth, and I to the fourth is going to equal to positive 1. Now that's the fact right there that we're going to use in order to simplify these terms, because I raised to any multiple of 4 is always equal to 1. What I mean by that is that this pattern repeats itself. So what that means is that not only is I to the fourth equal to 1, but I to the 8th, and I to the 12th, and I to the 16th. Any multiple of 4, if that's the exponent on an I, that's going to equal to 1. So watch carefully how we're going to simplify this. And what we're going to do is we're going to say, okay, I to the 28th is really I to the 4th. And then how many times does 4 go into 28 evenly? Well, it goes in 7 times, and there's nothing left over. And so that's just going to be I to the 4th raised to the 7th. Okay, go to the next one, which is I to the 37th. So I to the 4th, how many times does 4 go into 37 equally? Well, it goes in 9 times, since 9 times 4 is 36. And there is 1 left over, so I'm going to have to multiply by an additional I there. Okay, finally, I to the 51st is going to be I to the 4th. And then how many times does 4 go into 51 evenly? Well, that would be 12 times, since 4 times 12 is 48, and there are 3 i's left over, so I'm going to end up with I cubed there. Okay, so now every time we see I to the 4th, that's just equal to 1. So this is going to be 1 to the 7th power, which is going to be 1, plus I to the 4th is 1, raised to the 9th is 1, and 1 times I is I. And then finally, I'm going to use this here so that you can see, I to the 4th, whoops, let me back up here, I don't want to use a pen, I want to use a highlighter. I to the 4th raised to the 12th, that is going to equal to 1. And then I cubed from back over here is going to equal to negative I. And so this is going to be minus I here, and then just collect the like terms, and that's going to give you an answer of 1. Okay, example 2, just one more example of the exact same thing. And I'm going to start over here just to kind of give myself some space. And so I to the 21st, I'm going to start by writing that as I to the 4th, asking myself, how many times does 4 go evenly into 21? And that would be 5 times with 1 left over. Plus, for I to the 54th, 4 goes into 54 evenly 13 times. 4 times 13 is 52. And so that means that there's going to be 2 of those left over. And I'm going to, well, no, I'm not going to erase that. I tried to erase it, and it didn't work. So I'm just going to have to come down to the next line to show you the next part. So plus I to the 12th, which is going to be I to the 4th, raised to the 3rd, with none left over. And so this is going to equal my final answer. This is going to cancel since it's just 1, and that's going to be I. This is going to cancel and multiply by I squared, which is negative 1. And then I to the 4th cubed is positive 1, and that will just combine to give me I. Okay, any questions at all on the P chapter, please feel free to reach out via my office hours or by email. Hope you guys have a great day.